Okay, so I wanted to do one special little problem with you here, which is a problem that a lot of students struggle with. I call it a you try it problem. What I've done is I've taken a snapshot of a homework problem that a lot of students struggle with. So it says, find the exact value of each part labeled with a variable in the figure. So notice 30 degrees, 90 degrees, aha. So we notice right away we're dealing with a 30, 60, 90 triangle. But go back to how we originally constructed a 30, 60, 90 triangle. And remember how we started off with an equilateral triangle? So 60, 60, 60 degrees, right? Remember we bisected this angle? And we said for simplicity, pretend you had an equilateral triangle that was, remember, 2, and this was in our notes in the past. So let's just start with 2, 2, 2 for our equilateral triangle. Well, if you, in essence, wipe away half of this triangle now you've got yourself a 30, 60, 90 triangle, and you rethink about those relationships. Then this must be 1, and we had figured on this being the square root of 3 then, with just a little Pythagorean theorem. So we know that this here, since that angle was bisected, this is our 30, this is our 60, this is our 90. So that was just us in the past, I'm just going to say construction. That was just us constructing a 30, 60, 90 triangle. Well, then you can start to observe relationships. Like, for example, if you're looking at a 30-degree angle, the piece across from it is half of the hypotenuse. And adjacent to the 30 degrees is, you take the leg opposite and multiply it by root 3. So you can start to notice things like that. But let's go back over to the initial question. Here we are at a 30-degree angle. They're asking us for various pieces of the triangle. Well, if you look directly across it, and think about, okay, what's the relationship to the hypotenuse? Well, notice I have the answers already typed in, but you have to think about why that is. So according to our original construction, if you're standing at 30 and you look across from it, notice that 1 is half of 2. Okay, so the piece across has to be half of 21. Well, notice 21 divided by 2 is 10.5, which is exactly the answer. So I had already, done this problem and typed in the answers, so now we're just thinking about how to get them. All right, let's try that again. Notice that if you're standing at 30 degrees, what's the relationship between the piece directly opposite the 30 degrees and the adjacent piece? Well, directly opposite, and I always resort back to our original construction. So how do I get from the piece directly opposite to the adjacent piece? Well, I multiply by root 3. So I'd have to take whatever A is, which I already know, and multiply it by root 3. Well, notice 10.5 really means 21 halves. And notice 21 halves times root 3 is 21 root 3 over 2. You see? So again, if I take the piece directly across from the 30 degrees and multiply it by root 3, I will have this adjacent piece. So now we see that relationship. Okay, now we're looking for n, little n. So you kind of have to rethink about where you're sitting and where you're anchored, because notice you've moved on to this other side. So I'll re-highlight that. In fact, I'm going to highlight that in another color. Okay, so now here's my 60. This little guy in here, that's my 30. So I'm dealing with the smaller little triangle there is yet another 30, 60, 90 triangle. So, but now we know A, we know we have it filled in. We know that's 10.5, 10.5. So again, if I have the adjacent piece to the 30 degrees, how do I get the piece opposite? So just like here, if I have the adjacent piece, how do I get the piece opposite? Well, a leg opposite. Well, I'm going to have to take and divide by root 3. So, if you think about it, all right, again, you have the adjacent side to the 30-degree angle, 10.5, and if you divide that by root 3, well, 21 halves divided by root 3 means the same thing as 21 halves times by 1 over root 3, which is 21 over 2 root 3, but then you got to rationalize it, so multiply by root, pen's being fussy, multiply by root 3 over root 3, and eventually you will arrive at 21 root 3 over 6. But 21 root 3 over 6 reduces to 7 root 3 over 2. Now notice, and I'm just going to scoot on down here, notice you could do those in any order. So again, the 21 root 3 over 6 reduces down to 7 root 3 over 2, which, again, I had targeted this little m piece right here. Okay? And then I always think it's easier. So now we know this is 10.5. We know the piece opposite is, 7 root 3 over 2. And what I like to think, if I'm sitting up here at my 30-degree angle, if I know the side opposite, the hypotenuse is always double the side opposite. So if I take, this and double it, I'll have this, okay? Because 7 root 3 over 2 times 2, well, that's just going to cancel, and you're going to be left with 7 root 3. So now I know little n is the hypotenuse, and I'm just going to kind of make a recipe, which is double the side opposite the 30-degree angle. So again, it's all about these angle and side relationships. So if you just want to kind of make a general recipe for yourself, the side across from a 30-degree angle, directly across from it, if you take and double it, you'll have yourself the hypotenuse. And if you take the side directly opposite the 30-degree angle and multiply it by root 3, you'll have the adjacent side. Okay, hope that helps. I just wanted to reiterate, always go back to our original 30, 60, 90 construction, and, perhaps it would help you to even take a note card and put it into words, things like I did right here, that on that original 30, 60, 90 construction, that the hypotenuse is double the side opposite the 30-degree angle, and just make little recipes like that. Okay, good luck out there.